Welcome to 201X. I am so glad you decided to take this course. My name is Simona, and I will be the main instructor for this course. You may be taking this course for different reasons. You may just be curious about how the world works and why things are shaped the way they are and how they carry the loads that they carry. Or you may be just curious about engineering. You may be wanting to take a peek at what an engineering class looks like. Or you may already have a career. You may be a product designer. And you may be wanting to be able to design your structures in a little more effective way and your products to deform the way you want and to carry the load that you want. All these reasons are excellent reasons to be here. This is going to be a class that will introduce you to the knowledge necessary to predict the response of structural elements. And we want to make sure that the structural elements will not fail. We want to prevent failure. So what do we mean by structural failure? We can think of simple examples. Say that you are in charge of designing a diving board. So here is the wall that will support your diving board, and here is your diving board. And this looks like a totally fine diving board, right? Here is your water, and you think you did a good job. This looks like a good diving board. But how do you test it? Well, you need to load it. So you step on your diving board. So this would not be a good design, though, once you step on it, if the diving board is so flexible that it will touch the water. The other thing you would want to make sure that the diving board doesn't do is that the diving board will not just snap off when you step on it. Bad things. This is what we call structural failures. You do not want your structure to fail. And I know that these are intuitive knowledge that you already have about the fact that structures can fail. If you want to break this stick, I'm sure you're not just going to grab it and pull on it. You know that no matter how hard I'm going to pull on this stick, it's not going to break. You know that if I want to break this stick, I'm going to grab it in two spots and do this and bend it. And by bending it, I can break it. And look, it breaks not where I hold it, not where I apply my forces. It breaks in the middle. And why does it break there? And the other thing that you know is that if I take this stick and I bend the thin part of it, I can bend it without breaking it. You cannot push on a string. Why can't you push on a string? Or if you want to cross a river and you see a plank on the river and you want to make sure that you can step on it without breaking it, you first try with the foot a little bit, put a little load. And you know that somehow the way that the structure deforms under that little load is connected to the way it will deform when you put your whole load on it. So you kind of get a sense of how the structure will deform under a certain amount of load. So all these are intuitive knowledge that you have. And what we want to add to this intuitive knowledge is the mathematical understanding of the relationships between the load that you put in the structure and what happens inside the structure that may cause the structure to break. So we're going to do this in a number of simple elemental components of the structure that we call structural elements. So we will do this kind of analysis of the response of the structure for three types of structures. We're going to look at bars in axial loading. We will look at shafts loaded in torsion. So this is a modal loading in which you twist things around. These are important load-bearing structure that behaves like this, like the drive shaft in your car. And then we're going to look at the response of beams in bending, like what we did with our stick when we bent it. So these are elements of structures. If you look around you, you will see different components of structure, and each of these components may have a predominant way of carrying load that may be either axial loading, torsion, or bending. And by understanding how we predict the response of these kind of elements, we're going to be on our way to understanding more about structural mechanics. And that's going to be a foundation of structural mechanics that you acquire in 201. So we're going to go beyond the intuition into mathematics. I know that this may be a little scary, and there are prerequisites, and I don't want those prerequisites to scare you off, because really we want just a very basic foundation of math, and we're going to help you through it. We're going to have the first week, we're going to have an introduction to integrals and other things you're going to need, and we're going to be with you all the way so that in this journey, this 201X journey that we're going to do together, we're going to be partners. I'm going to help you out. You're going to work hard. This is a tough class. But at the end of it, you're going to have a whole tool belts full of knowledge and little tools that you can use as engineers, as structural engineers, and you're going to be proud of having taken this class. You're going to learn so much. It's going to be good. Come with us. Stick with it. You're going to get through it.